In this beginner's video on Tekla Structural Designer, you are going to be learning the necessary settings that you need to do in Tekla Structural Designer, how to model, load, analyze, and design reinforced concrete building project completely, and then we produce the detailed drawing as well as the report successfully. And so you are going to be gaining a very useful knowledge in this video. So just stay connected. You are very welcome to this presentation. So let us start. Once you launch Tekla Structural Designer's software, what you see is this window, just like this. You can see we have only two tabs here. We have the home tabs and then the Windows tabs. Okay, so we will be starting from creating a new project. So to create a new project, you have to click on this new icon, or you come to file, or use this other new icon right here. So if I click on the file and then select new right here, so this will create a new project for us, just like this. You can see. So once you create a new project, you now have too many tabs right there. You can see we have the beams integrations, we have the model, edit, load, analyze, design, and the rest of that. Okay, which we will be actually going through as we make progress in this presentation. Okay, so now once you have created this, you need to save this as pertaining to the project you are actually working on. Okay, so I will click on the file menu and click on the save as. All right, so in this we are looking at a complete, we'll be looking at complete design of a reinforced concrete building. So I will use this as the project name. I click on save. So after saving the project, you now proceed. Before you start to model, you have to carry out some important settings. Okay, so now you have to go to the settings under the home tab, click on these settings. So in the setting dialog, the first thing you should set is the code of practice that you want to use for the design of the reinforced concrete elements. So at default, you have these UK settings right there, very active. If you click in these provisions, you notice I have Australia settings as well. If you want to import more codes, you have to come to these import options, and then you see more countries code right here, and then you choose the one that you wish to use. Okay, so once you choose any one, for instance, if I choose the Singapore and then I click on the OK option, you see here I've changed to Singapore, but you have to click on the active to make sure that this is the active code. All right, but we will get back to the UK settings and then we make it active, which is the code we are going to be working with. All right, so after which we will navigate to the unit. You should be able to know the unit of your dimensions successfully, and here you can make changes depending on what your preferences is. After which you come to the settings, design code settings. Here are other code, actions codes that relates to this United Kingdom Euro code that we actually selected. All right, so we come to the design settings right here. In the design settings, we'll go over to the concrete, and then you see the cast in place options, expand it, and then you come to the beam options. Here you can choose the minimum reinforcement and the maximum reinforcement. You actually expected the software programs to work in between. You understand, the same thing applicable to columns and wall as well as the slab successfully. So if you click in this provision now, you can see here you have various sizes of reinforcement size right there, so you can be able to select right here. But for the grade of concrete, we only have 500. I will take you to where you can create more of these grades successfully. Okay, so you click on the OK options. We go by this 12 millimeters minimum bar size. Okay, and then the maximum will be 25 millimeters diameters of the reinforcement, okay, for the beams. So we go also by the default for the columns successfully. So I will minimize this. The next provisions I will take you to where you can do some important settings right here is the scene. This scene is a place where you can be able to set the color of your reinforced concrete members, the beams, the slab, the columns, as well as the walls. All right, you can set it here. All right, like if you come to member provisions right here, and then you navigate to the concrete provisions, you can see over here. So you see the beam reinforcement, you see the color, and then the column precast, you see the color. So you can be able to assign colors all right, so as to visualize very much better while you are actually carry out your modeling. Another thing you should also understand here is that if you check my window, the scene area, you see it is black. You can change it to white using these provisions. You see, if I change it to white right here now and click on OK, that will change to white. Okay, so you can see it is white now. If I get back here, okay, and then I decide to switch it back to black, I can as well click on the OK options and switch it back to black, just like this. All right, so that is all that are necessary in these provisions that we have actually checked successfully. All right, so we proceed to set the material. So come to this material tab here, right here, click on it. So once you click on this material tab, you will have the material dialog where you can be able to set the grade of concrete. As I said earlier, we have only 500 grade, so you can add through these provisions. You provide the class, you provide the modulus of elasticity, you provide the detailing prefix right here, and as well as the partial safety factor. And then you'll be able to click on the OK to create a new material, a new grade of concrete successfully. So that is what you do in these provisions. But by then you have to be sure of the country in which you are actually adding these grades. You should have all the necessary informations right there. Okay, so here are the default bold, and we are not dealing with steel members. All right, so but this particular provisions is very important. Over here you have the system unit and the rest of that. Okay, so we proceed to the next stage in this presentation. Let's close this dialog. So the next stage in these presentations, now we are done with all our necessary important settings. We will proceed to the modeling tab right here. So in this modeling tab, we'll start by creating levels. You have to create level first. Okay, so if you double click on this or click once on these constructions levels right here. Okay, so you can be able to have this construction level dialog. Okay, on this you have the a kind of a table, but just use this insert above options to insert more tables. I will explain these tables shortly. So we need like 4 floors. Okay, 4 levels. Okay, so we see 1 2 3 4 levels. All right, now come to the type right here. We see TOF. This simply means top of foundation. All right, so we're using SXL, which is structural slab level. All right, so these are going to be structural slab level, while the TOX is the top of steel. Okay, so you have to be careful on how you select this. It's very important. The height of the building is going to be 3 meter, 3 meter, 3 meter, 3 meter right here. Okay, and again over here where you have the source is how to actually make stories similar. Okay, for instance, if I want to make story 1 to be similar to story 2 and to be similar to story 3, I will change these provisions to 1, because here we have it to be story 1. Okay, so this simply means story 1 and 2 are similar. I want to make 3 similar as well. I change it to 1. Okay, so all of these are similar. All right, the only unique story we have is this story 4 right here. So for the slab thickness over here, we will have 180 millimeter slab thickness right here. 180 millimeter slab thickness, just like this, and then 180 millimeters. All right, so if you wouldn't want to have slab in any of these stories, you can actually uncheck this provision, just like this. All right, but we have checked it because we need slab in all the stories. Okay, now after which we click on the OK options. We are done with this setting. So at the base is the top of foundation, as you can see right here. Okay, so click on the OK options. We are done with setting our stories. So how and where do you see these stories that we have set? Come and activate this. You see this icon right here. Just click on it, and then you can see structure and levels. Expand these levels, and then you can see the level we created from the base to 1 2 up to 4. You can see over there, so you can be able to switch between it successfully. All right, so we now at the base level. Okay, so we want to start to create our grid lines. Okay, so to create grid lines, you have to also come to the modeling tab, and then you see over here we'll be using this rectangular wizard. Okay, before then, we are going to be referencing this our grid line set out to set the grid line successfully. You can see. So I will get back and then I come to these provisions and click on the rectangular wizard. So I have this. So you can give the grid name right here. But I'm going with the default grid lane, which is AG1. You can also change the color of the grid. If you click in this provision, there are so many colors you change. But I will be going with this color as well. I click on the next option. Okay, so now in these provisions, I go to next and then next. In this place now, this is the X directions extent of the grid lines. So here we'll be doing the settings. Okay, so for the X direction, let's get back to this grid. So this is the X directions. We have 3 meter, 4 meter, 3 meter, and 2 meters. Okay, 3 meter, 4, 3, 2. Okay, so let's get back and then do the settings right there. So I go to the irregular. So the first space we have is 3 meter. You do a comma. 4 meter, you do a comma. 3 meter, you do a comma again, and then 2 meter, just like this. All right. So we are done in the X directions grid lines. So we go to next option, and then here in the Y direction grid lines, we go to the regular as well. Let's navigate to our referenced grid lines. So here we have 3, 4, 5, and 2. 3, 4, 5, and 2. So let's get back here. So we have 3, 4, 5, and 2, just like this. You can see. So this is the grid lines that we actually needed for this model. I click on the next options, and then I click on finished to actually get our grid lines and navigate back. So here is the grid line, you can see. All right. So if you want to dimension this grid line, it's as easy as using this dimension tab and then pick the first point, pick the second point, and then pick a point to have it placed successfully, just like this. So if you want to delete your dimension, you can just select it and use the delete options right here to get rid of it. So at this point, we want to start to model the reinforced concrete columns. To model, you have to be at the ST base to model. You understand? You have to be at the ST base. Okay, but now I want to divide the window into 2 parts so that I will have the 2D window and the 3D windows. For me to do that, I will click on this 3D windows, okay, and then right click. I use these options to tie the window vertical. All right, so you can see we have separated the 3D and the 2D windows just like this. You can see. So you can also use these provisions to adjust it, okay, so that you can increase the visibilities of any of the windows successfully, just like this. All right, let us start to model. We want to start by creating the reinforced concrete column. So for the reinforced concrete column, so to activate each of the windows, you just have to click on it to activate it. Click on it to activate it, just like this. Okay, so we want to model here. So we click here to activate this window successfully. All right, so we get to the reinforced concrete. You can see over here concrete panel, and then you see the beams and the columns right here. I click in these provisions. You see we have precast columns, and then we have the column, normal column. You can see. So now we click on this. So once you click on the column, you have to see this dialog. Okay. So in this dialog, you see the top level, you can see the base level, and then it depends on where you are referencing. Okay, so I want this column I want to place now to connect the base and this ST4 level. Okay, so you can select in this provision and be able to select where you actually wanted the columns to connect successfully. All right, but in this case, it's going to connect the base and the ST4, which is the last floor level. All right, so the characteristics is columns. We have the material type is concrete. Okay, there are various materials here that you can use, but here the material is concrete, and then the fabrications is cast in place right here. If you scroll down over here, we have the rotations, all right, which you can use to rotate the columns orientations. All right, down with concrete type is normal concrete, and then the concrete class here we have various concrete class, okay, which you can choose, but we use this one. Okay, auto design is check. All right, and then we scroll down over here where we have sections. You see the default section we have is 400 by 400. So we'll be creating a new section by clicking on that. And then over here you have 300 by 300 millimeter sections of the column. So this is the section we are going to be using. So we have a circular, we have various other shape, okay, that you can be able to model successfully. You use the rectangular shape, okay, to be able to model this square column successfully. All right, after we click on the OK options, and then that is being taken. All right, another provision that you need to make changes is this automatic alignment. Uncheck this provision so that the column will actually pass through the centroid of the grid line successfully. If you scroll down here, you see the reinforcements and all of this has been making change. We have made change to this successfully. Every other thing, leave it positive, and then we start to place our reinforced concrete column. All right, so placing our reinforced concrete columns, for this particular column, I want it to actually go in this provision within this place. So I'll select here to have this column that connects the foundations and the top stories. Okay, then I will select in this provision right here to have these particular columns successfully. So the next column is going to connect the foundation and the XT3, which is the story 3 right there. So I have that selected. The materials and the properties are the same. You can see, then I placed it just like this. I placed this one just like this, and then this one, and then this last provision. So to place the column, you just have to do a window over the grid line intersections to actually place it. You can also click at the grid line intersection to place it successfully. All right. So we are done modeling our column, as you can see here in this 3D successfully. Okay. Now the next thing we'll model is the beam, reinforced concrete beam. So you have to escape by using the escape key. Each time you finish with any command, use the escape key on the keyboard to actually escape that command successfully before you commence another command. All right. So being on this window, we click on the beam right here. I select the beam. So in these provisions, I will now have to check over here the characteristics, the material, the constructions, and then the fabrications. Then the beam linearity is going to be straight. You know, we have curved beam as well. All right. So we have the rotations is going to be 0. We have the concrete type is going to be normal, and then the concrete class is still the same thing. And then if you check here, you see the auto design is checked, meaning once you run analysis and design, it's going to automatically design all of the structural elements. Okay, so over here we have the beam sections. Here is gravity only, simply means you are subjecting the beam to the force of gravity load only. Okay, but we wouldn't do that, so you don't need to check these provisions. Right, so select in these provisions and click on the edit so we can edit the sections. So we are going to be having a sections of 250 by 500. So let's go by these sections. So we go by default section right here. All right, then we proceed to the measure alignment is top. No, we have to uncheck this automatic alignment so that the beam can also be centralized, okay, with the grid line. So every other things here, you leave it positive, just like this. And then to place the beam at this floor, you just have to click somewhere, hold the left mouse button and do a window over the grid line intersections and the columns successfully, just like this. You know, we are at story base. Okay, so we are at story base. We wouldn't want beam at this story base. Okay, because if I place this beam now at this story base, it's going to appear at the foundation level. Okay, so now you need to navigate to story 1. So to navigate to story 1, you have to click on the ST1. Double click on this ST1. Double click, and then you see this is story 1. From here, we will now place the reinforced concrete beam. So click in these provisions and then make sure all the settings are intact. Right, so after which uncheck these provisions and then do a window over this. Release your hands to place the beam successfully, just like this. You can see now the beam we are placed on story 1. It is being replicated on story 2 as well as story 3 because these stories are unique story. Sorry, these stories are similar stories. All right, except the topmost story that is unique. All right, so that is what happened. Now we want to place the beam at the topmost stories here. You need to navigate through these provisions, double click here to get to the top story. Sorry, you see this has changed here because we have already activated this provision before we actually double click on the ST4. Okay, so we can close this from here to get back to 3D because we are going to review from here the 3D. So I click here to activate this. Okay, escape to get rid of the previous command, and then I double click here. This will take me to the story 4, which is the last floor. All right, so we want to place a beam here as well. So click here and then select the beam. All right, now check all the characteristics and the materials as well as the beam properties. Everything is fine. So the automatic alignment, uncheck this provision, and then you just have to do a window over this relay intersection to have it placed. Do a window over this one to have it placed, just like this, so you can see what we have here. All right, so now we are done with the beams and columns. We will proceed to start to model the reinforced concrete slab. We go to the story one for the reinforced concrete slab modeling. If you check over here, you can see slab panel right here. So here you do everything about slab in modeling, openings, and the rest of that. So we click on the slab on beam options. In the drop down menu, you can see the flat slab right there, precast, composite slab, and the general, where you can see steel deck, timber deck, as well as the general. All right, so you know this Tekla Structural Designer is actually capable of designing steel, concrete, and timber successfully. So it has 3 design engine. You understand? Okay, now you see at this point I want to say that you should like the video, and don't forget to subscribe if you are new to the channel. If you are not subscribed yet, subscribe to our channel. Okay, let us go with the slab modeling. So we use the slab on beam, select that options. Now in this provision we will scroll down. You see the depth of the slab is being applied successfully in our previous settings. Okay, so we don't have anything much to set. And then over here, what is also important is the one-way or two-way slab. It depends on how you want to apply the slab successfully. Okay, so but in this case we'll be designing all the slab as a two-way slab. Okay, all right, so over here the overall depth is here, and then you can check the concrete class as well. We go by this, so every other things you can leave it at default. After which you can do a window over this provision to have your slab placed. So you can see how I place the slab automatically for all the floors. You can see the first, second, and the third floors. It is only the fourth floor that is unique. So you see what happens here. All right. Okay, now we navigate to the fourth floor, so we can also apply the slab as well. So we escape the command. Over here, we go back to the slab on beam, and then we have it selected just like this. And then we'll make all the necessary material changes over here. All right, and then you just placed it just like this, and then placed it here. All right, so we are able to model the slab successfully. Okay, so just escape on the keyboard to get rid of the command. At this point, we want to see how we can actually validate this model. To validate the model, you can use this validate options or tabs, or you can use validate also in the quick access tool right here. Right, so if I click on validate here, you can see everything is validated over here. All right, now you want to be creating a kind of let's go to the ST1. So we want to create a kind of opening on these slabs. These openings we actually meant for the staircase. Okay, so now we go to this provision, and then you can see the column drop panels. You can see the slab openings and then slab overhang. All right, so we want to use this option of slab opening. Click on it. So now it is in this provision. You can set the type of opening, whether circular or rectangular. All right, so and then the rotations over here can be set as well. So now if I pick at this point, take my hand all the way to this point and click, this will create an opening for us here. And in the 3D you can see the openings goes all through the provisions, all right, in all the floors successfully. Okay, now if I escape from here, another thing I want to show you, you can see we are having geometry issue right here. Okay, geometry issue right here. You see model geometry, because the slab cut along the beams, so we are having this geometry issue. Okay, so if you really want to have the geometry issue, you have to move the point of openings out from the beams, and this will be corrected. So this is not an issue. All right, so we make progress. At this point we will now start to load this model. So just click in these provisions and then try to escape to get rid of the command just like this. So we are done modeling our building project just like this. We want to load this building. So to load it, you need to carry out the loading combination settings. All right, so for the loading combination settings, you will have to come to the loading provisions, this provision, this load tab. Okay, now click on the load cases. So in Tekla Structural Designer, we have a default load cases arrangement. You can see the safe weight right there, and then we see the slab safe weight right there. Okay, all of these are being applied at default, so you don't need to make changes to all of these two options. Okay, but from the dead load, the services and the imposed load, you need to apply it, a figure to it. All right, so based on the purpose of the structure. All right, so if you want to create an additional let's say I want to create an additional load, whether additional imposed load and the rest of that, or lead load, you just have to add from here. You can see load case here, over here, give it a name, and then the type and the purpose of it, you can also select it from here. Okay, so I can also delete by selecting it and then click on delete from here. All right, so we go by this default. So what we do is just click on the OK option. So now you click on the OK options. We will now proceed to load this model. So I just have to click in this window to activate it, and then you come to where we have a select load case, and then come over here. You see these are the loads right here. So the first load we'll be applying is the dead load, additional dead load on this slab. This is a residential structure, so we use the imposed load based on the purpose of the structure. All right, so we'll apply that successfully. So additional dead load, we are going to be using floor. This level load will apply the load on all the slab automatically. So we just have to make sure you activate the type of load, whether dead load, whether live load, in these provisions. Once you have it activated, come to level load, click on it. So in this load properties dialog, so you just have to key in the load. I want to be using additional dead load to be 1.5. This is an additional dead load. All right, so it is not a live load, it is not an imposed load, just an additional dead load that consists of the partitions and other important things. So after we just click on one of the slab to have the load placed. So if you click on one of the slab, you see the load has been placed, but you notice it is not being reflected in the 3D. So you need to activate the load to have it reflect right here. So how do you do that? You have to come to this scene content. So in the scene content, you now have to look at load. You can see over here loading options. If you click in this arrow, you see various type of load, but you just click inside here and then check this text and click on OK options. Then you can select in this window and then pull out, activate the dead load, so you can see the load right here, 1.5 being applied successfully. Okay, so now we move to the ST4. We need to apply the same load right here. Okay, so now we just have to click here, go back to the dead load, and then you use the level load. Over here we use 1.5. We use 1.5 right here, and then we click here to have the load being placed on the slab. You can see, just like this. Okay, now we want to apply it service load, so choose the service load from here. You can see, then first of all escape the previous and then select the service load from here, and then for the service load we also use the level load. So the service load is going to be 1 kilonewton per square meters. Just select it just like this and pick on these provisions to have it placed successfully. All right, navigate to the ST1 right here and then escape these loads, come back to these provisions and then use service load, click on the level, and then over here you change it to 1 kilonewton per square meters. Select in the slab to have it just like this. You can see the next load we are going to be applying is the live load or the imposed load. So this is due to the purpose of the building. So this building is a residential structure, so the imposed load is supposed to be 1.5 kilonewton per square meters. You have to activate it from here, the imposed load, after which you click on this provision where you have the level load as well. So all of this load is on the slab. Okay, 1.5 kilonewton per square meters, and then select on the slab to have it placed successfully. Sorry, this is not properly applied. So you can see over here we are now having a service. All right, so you can actually be able to undo from here just like this. Okay, so select in this provision or in this window, and then select here, click on impose load, after which come over here and then click on level load, and then for the imposed load is 1.5, change it to 1.5 right here, and then select on the slab to have it applied. You can see, so you go back to the ST4, but by then you have to escape this command, and then you click on the ST4 right here. So escape as well and change from this load case provisions to impose load. All right, and then use this level load. Okay, at this point we are keying in 1.5, and then select on this slab to have it placed just like this. Okay, now we need to apply the wall load on these beams. Okay, to apply a wall load, just have to escape from this load command, and then we come to the ST1. So wall load is actually a dead load. Okay, so we just have to select the dead load. So having activated the dead load, you now proceed. Now, since the load is actually going to be on the beams, which is the member, you can use the perimeters load. This is the perimeter load. So these particular provisions allow the load to be at the perimeters of the slab level. Okay, but you can also use the full UDL, which is the uniformly distributed load, which is under a member load. Okay, but let's use this one. All right, so I click on it. So once you click on that, you have the property right here. So over here, you need to set the load value. So the load value in this case will be using 10.4 kilonewton per square meters. Also, do not forget to actually look at the directions of the load. Okay, this is a gravitational load. Okay, acting in the Z directions. If you select here, there are other directions in which you can apply the load successfully. So after which, selecting it on member one by one may take time. So you can do a window just like this. So you do a window, you see it is also difficult to do a window over this over the structure, over the floor. So you can also use the member to apply it by selecting on the members. So if I pick on this member, the loads are not actually being applied successfully. Okay, so it will be fine. You do that in the 3D options. Okay, so let's just escape this. Click and escape. All right, so we also have to activate the dead load. Click on the member load, which is the full UDL. So here is the load value. So over here, just activate this window, click on it again. Make sure it is 10.4 kilonewton per square meter. So just select on this member, you can see that is the load. You picked it to have it placed all through the floors on the member. So I pick on this member, I pick on this member. So the best way to apply this load is in 3D. All right, so just pick on it just like this, and then you pick on this successfully. So you just have to orbit this, right click your mouse and then move your hand to orbit it. So we place the load right here, placed it here, and then you place the member load, because these beams will be carrying a kind of wall on it. You see, this one is placed wrongly, we'll correct it. So you just have to be careful where you are placing it to avoid unnecessary mistakes. All right, placed it just like this. So we'll orbit this way. All right, so we have placed that load successfully. For this one that is wrongly placed, just have to escape the command first. Escape the commands, and then you can just select the load just like this, and then use the delete option from here to get rid of it. So for the internal beams, we may not necessarily have load on it. because we are not designing for those beams to bear load. Okay, so the internal will be using another material at all, which are weightless material. All right, so after which you see that we have successfully loaded this structure. All the necessary load has been done successfully. So just save this model. All right, then validate it. So validating it, you can see over here we are still having this slab openings issue right here. Okay, but it won't affect our analysis. Just as I said earlier, you can correct this by adjusting this opening out from this beam successfully. Okay, so at this point we want to go into the analysis and design of this model. So for the analysis and design of this model, we'll go to the design tab right here. So in the design tab, you can go to settings, but as first go to analysis tab, click on this settings right there, and then in this settings you can see that we have FE chest down. Okay, FE is chest down. So the Tekla Structural Designer actually uses a finite element method to actually analyze the slab. That is why you see it having this FE. There is nothing like heat lines. Okay, unlike proto structures that do those heat lines and as well as FE, but in this case it is only FE. Okay, so you should have this FE selected just like this under concrete modify factors, and then you have all of this. For the analysis, it is going to start from the first order nonlinear analysis successfully. So you click on the OK options. All right, so we want to analyze this model now, but we'll use the design tab, because in the design tab you can see we have analysis and design. Okay, so once you use this design or statics, simply means it's going to analyze the model first and at the same time design it. Okay, so this design concrete statics will actually design the first concrete. Okay, and then we can see design or gravity. Design or gravity simply means it's going to factor in only the gravitational loads. Okay, it's not going to factor anything like horizontal load, you understand. But when you're using these options, it's going to factor in both the gravitational load and as well as the horizontal load for the analysis and design of these structural elements of this model successfully. Okay, so the same thing applicable to analysis over here. So, but we just have to go to design, so we do the analysis and design at once, right, in these provisions. Okay, so that is what we are going to do right away. But before we actually carry out the analysis and design, we need to create our loading combinations. All right, because there is no load combination. If you come to this tab of load combination, you notice none. We have nothing here. So you need to create load combinations now. Okay, so come to the load options and then click on this load cases, and then over here you see here are the load cases that we have applied successfully on this structure. Come to the combinations. All right, so in this combinations options you can click on the add to actually add the combination just like this. So you can give the combination a name. You can say total load, and then click on the combination from here to be able to move this load to these other provisions. So these are the necessary load we are going to use for the design, not these ones. So after which you can actually click on the OK options to create the combinations of the loads you applied successfully. Okay, but we want to be using an automatic combination. So how do you use that? I get back here, select on this, and then I can delete these combinations I just created by using the delete options to get rid of that. Okay, so after which I click on this generate. You see these options. So I click on that. So this is the combination generator window. Okay, so we use the second table. This is the combination for design of structural members. All right, based on this table in the code. Okay, so we can go by this table in the code, and then we have to uncheck all of this. So choose this table right there, and then over here we have the scenario. You can use the final scenario. Okay, click on the next options, and then we have the combinations right here, and then click on next again. Click on next again. Over here you have to check these provisions just like this. Okay, and then after which click on the finish option to have the loading combination created successfully. Then can click on the OK options. So now we are set to actually carry out the analysis and design. Okay, so we go to the design tab right here. But before we run analysis and design of this structure, I would like you to understand very important signs in Tekla Structural Designer. If you come over here under validate, you can see this sign. Okay, this validation sign right here. This simply means warning, but this sign of red cross simply means an error. Okay, this is an error. All right, so now this error is based on this slab opening that we created right here. Okay, because it cut across the beam line. Okay, that is why we have this particular error. Now this error, earlier I told you it may allow your analysis and design. Sometimes it may not allow your analysis and design. And if you actually allow your analysis and design, some of the members may not necessarily be designed. They will be having some warnings, you understand? So I will always advise that you should make sure you get rid of this type of error, okay, before you carry out your analysis. All right, so let us validate. So now we validate, you see the warning sign of the validations is gone, but we are still having the red cross right here. Okay, so how do we get rid of that? We can actually get rid of that by removing that, removing the, the opening. So if you select the opening just like this, and then you can use these options to remove it. So once you remove it, you can see that that red cross is gone. Then the model is perfect now. All right, so you just have to save this model again. All right, now we are good to go. So if you want to create an opening, that is the way to create it. All right, but in this we wouldn't want to add it in our analysis. Okay, so that is why I have to get rid of it. All right, so we make progress. Now we want to carry out the analysis of this model. So as I said earlier, we'll be doing the analysis and design at a go. All right, so we come over here, selecting these provisions, and then where you have these provisions, just select on this, select loading combinations, make sure this provision is none. Okay, so after which we move straight away to the analysis and design or statics. This we do analysis and design, so click on it. So once you click on it, just give the program some time to actually run the analysis. All right, so you can see that the analysis is done successfully. And then you can see that almost all the structural elements as past design, as you can see from here. All right, so now we want to look into the analysis. To look into the analysis or review the analysis, over here you can see the ratios, and then you can see the depth ratios, and then you see the statute right here. Okay, so if I put my cursor in this provision right now and I right click, and then I come over to the result view. So I want to view the analysis and design result right here. So I click right there. So this will actually activate this result windows. So in this result windows, what you just need to do, come over to where you have your combinations and activate the first combinations right here, this one. And after which, just proceed to click on the result right here. So this has given you an axial force on the model. So based on the result here is axial force. So if you select here, you can be able to view the shear measure. You can see here is the shear measure. You want to increase the shear, the result, you can increase it using these provisions, you can see. All right, so that is the shear measure, and then you can also view the moment measure right here. Here is the moment measure. And so if you right click over here, you can also be able to take screenshot of this. Okay, you can take screenshot of the work you are doing, and the screenshot is going to actually take within this window. All right, so you can also be able to check for the the deflection. If you click here, you can see the deflection shape of the model right there. So you can increase it using this provision. You can see. So you can also right click and then be able to view the animations. So you can see the animations of the deflected member. You can see right there. So you close this to stop this successfully, just like this. All right. So you can see the reactions as well by the time you activate this ID. All right, and then you come over here, activate reactions. So here are the reactions that goes to the foundations from the reinforced concrete column, which are the SGR load successfully. All right, so I can just get rid of that. Okay, so after which you can also view the slab or the slab final element plate. So for you to view that, you need to activate the final element in the method of analysis provision. Get rid of this as well to get back to the model, just like this. So come to these provisions and then click on the FE tester. So once this is active, and then you can come over to where you have the stressed right here, activate the stressed. So once you activate the stress, you can activate any of these, so you have the stresses on the slab, okay, based on the FE. All right, so you can activate the forces as well, and then be able to use the wood and hammer method to check, okay, as to complete the analysis successfully. So this is how this provision works. So you can also check for the moment as well. You can also check, activate this, make sure that forces is activated. Moment in the MX and MY. So you can also look at it in the MXY, which is the torsions, and then M1 major principal, and as well as M2 minor principal successfully. All right, then I can also place my cursor right here, right click, and then come to where you have this server view. This server view, I want to actually show you the final element plate. That is why I have to come to these provisions. All right, so if you click here and then click on the FE, this FE, you can see, so here are the final element plates that the program uses to actually analyze and design the first concrete slab successfully. So these are not headlines. So this is not an headlines method of analysis, okay? And also, I want to let you know we are having a master class in this program. So if you want to enroll in a master class, you can reach us through the link in the description of this video. All right, and also do not forget to like, do not also forget to subscribe to our channel Soft Raising. Okay, so let us make progress. So we are done with this. You can be able to just select this, right click, and then we can go to this result view, or you can use this review view again. So this will take us back to these provisions, and then you can go to the statute right there to see our model design statute, which every member has passed successfully. Okay, now so we can proceed to design the foundations. If you click in this provision to design the foundation, you have to navigate to the base level. So here is the base level. All right, so we are good to go to design the foundations right away. So for the foundations, you have to go to the foundation tab. So we are going to be considering part base. All right, so we just pick on the part base, and then make sure you select all of this. Do a window over the columns to insert this part base. Mind you, you can see the part base showing here, and they are not designed. All right, so they are not designed. So once you select it just like this, it will create a property dialog just like this. So in the property dialog, you can make changes that are necessary, like the concrete class. The depth, you can leave it. This is just like a default depth, and then the LY and the LX, which is the length of the footings, is just default, not designed yet. So once it is designed, all of that will be adjusted automatically. All right, and then if you scroll down, also very important information is the concrete cover. We have top and bottom to be 40 millimeters, okay, which are not bad. And then another important option here is the soil parameters, which is the soil bearing capacity. So we'll be using 150 kilonewton per square meters right here. So we use 150 kilonewton per square meter right here. All right, so if I scroll down, leave every other information here positive. Now we are good to go. Okay, so we want to design the footing. To design the footings, you can see over here, you see design part base. All right, so just click on this design part base. So you give it some time to carry out the design of the part base. All right, so the part base has been designed successfully. So you see we have 25 of it parts designed successfully. So now we are good to go. We want to start to check the members, and then we see how to start to produce the drawings, and then produce the report as well. So Ordinarily, we can't actually come to these provisions and then navigate to this structural view. So once you navigate to this structural view, this is what you have. So from here, we can begin to check the member. If you select this particular beam, right click, you can see some options here. Okay, with these options, if you select in these provisions, you can actually be able to view the shear force, bending moment, and as well as the maximum moment and shear forces on that beam successfully. You can see over here. And as well, you can be able to check the beams in terms of interactive design, just the way we do it in a Prota structure. You can click in these provisions and then you can see the beams right here and then the design successfully. So you can be able to check it right here. Also, the stirrups has been designed successfully right here. So the stirrup diameter is H8 right here. All right. So if you use H6, you can see it automatically check it out. You see it is failed. Right, so we use H8, but you can also change it to H10. It all depends on what you want. So this is how you carry out your interactive design in Tekla Structural Designer. The same thing applicable to the beams. We are having H16 diameter reinforcement and 12. So if you change these provisions maybe to like H8 right there, you can see that the beams are fed right in these provisions. Right, so now you have to take it back to 12. So 12 is also giving warning, and then some of the check has also failed. So you have to move it to 16 right there to have it designed successfully. Okay, so this is how you check your members successfully. Okay, now let's proceed to the columns. For the columns, you can just select the column, right click, and then just right click on this column, and then you go to the interactive design statics. All right, here is the column sections and the reinforcement arrangement. The stack length is 3 meters over here, and here is the concrete strength, and this is the sections. Right, so over here you can also see how to change the sections, and then you can see section has been changed and automatically designed successfully. You can see over here I can change it from here to 300 by 300, and this has also been automatically designed. Also, if you come to the principal bar size and the intermediate bar size over here, if you make changes, it will automatically have effect on the design. Over here, other checks has failed. And then here you can see the failure here because I changed the bar size to the smaller bar size. Okay, so I can change it back to 12 to have everything passed, and you can interact it by changing it to 16 if you want to use actually 16 for the reinforcement successfully. So this is how you can do your interaction with the reinforced concrete members successfully. For the tie, you can see over here we have it check. Okay, everything has passed here. You can see the interaction diagram for the reinforced concrete columns successfully. Okay, I click on the OK options. Now we can be able to produce these drawings one by one. Like you can select this, right click, and then be able to use this, create drawing option. Once you click on this, you have this DXF export references, okay, dialog. So just click on the OK options. All right, and then this will be exported these drawings to AutoCAD automatically. You see, here is the beam drawings successfully. All right, so now we proceed. The same thing applicable to columns. This is a way of exporting your drawing one by one. I will show you a way of exporting the drawing in groups, so you can be able to change your scale from your depends. So we go by 1:25 scale. Click on the OK options, and this will also export this column drawing just like this, okay, into AutoCAD successfully. I minimize this. All right. The same thing applicable to the footings. All right, you can be able to check this. Right click on the footings, and then you will see that you have a design member. Right, see check member. So if you select on this, you can see what we have. Every condition has passed successfully for the footings. Click on the close options. All right, then for the slab, if you want to actually design the reinforcement on the slab, you just have to come to where you have this design tab, and then if you check here, you can see slab design. All right, you can see slab design. So if you click on this slab design, give some time, it will design the slab. You can see this slab has been designed successfully. All right, okay, so now I can click in these provisions and also be able to get back to the structural view right there, and then I can proceed to validate the model just like this. Now we want to go into the proper drawing creations. All right, for the proper drawing creations, what you need to do is to go to drawing, draw options. Okay, so in these draw options, you can see all what you can be able to create. All right, so if you select in these provisions, come to the draw options, you can see that we have our foundation layout right here. So for the foundation layout, if you want to create a drawing for the foundation layout, you just have to click in this provision, foundation layout. So once you click here, you can see for the layer configurations and then the layer style and the rest of that is foundation layout. That the scale is 1:100. All right, so you can change the scale to 1:50. It all depends on your references. So we click on the OK options. This will automatically send these drawings to AutoCAD just like this. Here is the foundations and here are the reinforcement details of this foundation successfully. All right, so you can see it right here. Okay, so let's get back. Now we have created the foundation layout. We can be able to also create the beam schedule, the column schedule. So if you click on this beam, all right, you can see the current view does not contain any beam. All right, so because this is the active view, you understand. So you need to click on this view to make this active. So if you mark this active, you see the beam schedule is not actually prompting. You know why? Because the plan is actually at the foundation. So let's get back to the first floor. You can see now we have the beam schedule active just like this. So if you click on this beam schedule now, all right, you see we are good to go. Click on the OK option. So this will create the schedule into AutoCAD successfully just like this. So here are the beam schedule and the bar bending. You can see over here everything being drawn successfully. All right, so now we proceed to the column schedule. For the column schedule, if you select on this column schedule, and then you can be able to check this column. You know, we have too many columns, but all of these columns have been grouped into just 4 columns. You can see what Tekla Structural Designer does. You have too many columns, but Tekla Structural Designer design it and they group it into just 4 columns, just like this. All right, so these are the columns we will actually get the detail. All right, so this will replicate every other column. One of it is used to replicate every other column. That is how Tekla Structural Designer carry out design, and it makes life very easy. So once you click on the OK options and then click on the OK again, this will be produced in AutoCAD just like this. So here is the column schedule. You can see at this floor, what you have. This same thing you have here. Here there is no column. That's why I say this cross line, there is no column here. All of these columns are just ending just here. So this is the same thing at below, and this is the same thing at below. You can see over here. All right, so this one is a unique one. All right, so this is how the schedule is. Tekla Structural Designer actually make this very simple for us. All right, so now over here we want to create the main. I want to create the main. You can also create the slab mat detail. Like now we are in ST1. So if you click on these provisions, this will actually create the slab mat detail. Or you can see over here. So you can see you can also use like create the top reinforcement. You can also create the bottom reinforcement. All right. And then over here, you use these options of layout. Once you click on OK, so this will be created in AutoCAD. So if you expand this, you can see our slab mat detail right there. Okay, now we proceed to produce the drawings. Like we want to produce almost all the drawings. So what you do, you come to this drawings manager. So if you click on this drawing manager, so you'll see over here we have concrete columns. All right. So if you select here, there are so many options. You can also see concrete beams. All right. So let's, for instance, we want to create our concrete beams detail. So if you select on the concrete beams, you just have to click on add right here. So you can give it another name, or you can leave it with this name, and then click on the content right here. So you can see we have by group. So you can see show all members. If you right click from here, take it by level. So you can see that you can be able to create a drawing by clicking on it, hold it, drag it to this side. So these are the beams for the ST1 floor, which is the first floor. Okay, and these are the beams for the second floor, you can see, and these are the beams for the third floor, and these are the beams for the fourth floor. All right, so you can create it maybe one by one. You want to create the first floor, first, second floor, third, and so forth and so on. Or you want to actually create all the beams, you can actually have them just like this. So once you are done with this, click on the OK options. So once you click on the OK options, just use this view drawings options, this one. Click on this view drawing option, you have this interface. All right, to export it, click on OK options. So all of the beams will be exported to to AutoCAD. So this is the beams for the model from the first floor to the roof level or the last floor. So you can see that Tekla Structural Designer actually group these beams. Like this type of beam is 7 of it that you found in the model. It has grouped it together instead of having series of plenty of beams. You understand? It grouped the beams together successfully. That is one of the advantage of this program. Okay, so now over to this. You click on the these provisions and then change it to the concrete columns detail. All right, for the concrete column detail, click on the hard options, and then you can also be able to view the content from here. So you just take it by story, click show all, and then use these options. Okay, now you can see these are the concrete columns that we have over here. We have too many columns, but these have been grouped. For instance, if I drag all of this to this side, you have this, okay, as the concrete column. You can also select on it and then be able to adjust it successfully, just like this. Okay, so if you click on the OK options, you will also be able to view it on here, and then click on the OK to view it in AutoCAD. So if you open it in AutoCAD, you can see that among all the numbers of columns we have in the model is only 4 that has been grouped into. So these 4 now represent all the columns that you have in the model. So if you check over here, you can see the number of this type of column is 12 over here. So this one, the number of this type of column is 6 over here. The number of this type of column is 4. And then the number of this type of column is 3. You can see how Tekla Structural Designer group this. Okay, so these are things that makes this program more powerful. You understand? And these detailed drawings, you can see how they are very neat. You don't even have much things to actually work on. Like you cannot edit that much, except you can use our template to make it more visible and more brighten. You understand? So that is the drawing for the reinforced concrete column of the whole structure. You can see just these 4. All right, so come over to these provisions and then click on the OK options. So if you want to check the drawing for the foundations, all right, for the foundations, you can also come over to this provisions, and then if you click in this place, you can be able to look at the accelerated foundation details, this one. So once you click on that hard, you are going by this name, so view the content to see the parts you have. So it is also going to group some of these. I don't but I'm not too sure. All right, but just move this to these provisions. All right, after which you can be able to click on the OK options and then click on the OK. All right, click on this again. We are supposed to view the drawing through these provisions. Isolated footings, we have created the content right here. Click on OK and then view it from here. So this, we open this interface, and then you can be able to click on OK to view it in AutoCAD. So here are all the part footings. All right, being designed. Okay, so this has been designed successfully, and then this is 235, 235, and then you can see the part footage right here. And then you see over here, these are the grand total of the total reinforcement in this successfully. Okay, so now we have created almost all the drawings successfully. Okay, if you check over here, and then if you scroll down, we have actually created the slab reinforcement drawing using these provisions. Okay, that is the last structural element. Right, so just click on the OK options to get rid of this. Now we want to go into the report scene. The report. So for the report, click on this report tab, and then you need to come to this model report. So you have to be setting this model report in line with the member report. All right, so if you click on this right now, you can see we have various styles right here. Various styles. You can see building design, you can see every other stuff now, but you can actually create your own by clicking on the add right there, and then you give it a name as a, you can call it, let's say, beam report. Beam report. Just give it that simple name, beam report. So once you select beam report, come to the concrete expand this, and this is the beam. Move this to these provisions. So you can actually add both beams and columns, but I will just advise you do it one by one. Later you can now add it together. So this will give you the beam design summary. This will give you the beam group design summary. But this has not actually given you the calculations, the detailed calculations. So in this particular tab, you may not be able to get the detailed calculations of the beams. All right. So just click on this one, click on the beam report you created and make it active. All right. Click on OK. Now come to the member report. In the member report over here, you can also be able to create your own. So you can just create one and give it, you can see concrete beam created, because this is what is active from here. So if you select here, there are other options right there. So for the concrete beams, now come over here. What do you actually need from here? Okay, so over here you can say you need drawings. If you need a load, you can also add. All right. If you need the end reactions, you can also add. If you need the end reactions factors, you can also add. But what is necessary is the summary calculations, and then you also see the design calculation. This is the detailed calculations that I'm talking about. All right. So if you also check, you can see that we have the bending moment, you have the shear force, so you can add this to the report. All right. So we have the axial force diagram, the torsion, and the note. You can also add this. So as many of these informations you actually need here, you can add it successfully. All right. So after which, click on the OK options. So now to view this beam report, if you come over here, you have to make this active. This is the beam, concrete beam. Okay, this is what you created. You need to make it active, so you can see what is active here. Concrete beam summary, that is active. So this one is the one you created. You have to make it active. Okay. After which, come over to the show report. Click here, and this is going to combine the report you actually arrange in the model report and the one in the member report together to give you a complete report of that particular member in terms of the calculations, in terms of the bending moment, shear force diagram, and as well as the necessary informations you need to actually check the beam for a good design successfully. So you can see everything is done successfully. You can zoom this closely so you see it very well by holding down the control key on the keyboard and zoom it just like this. You can see it very much well now. So over here you can use the these provisions to adjust it just like this. You see the concrete beam design, beams cast in place concrete, regional code, United Kingdom Euro code design code. You can see over here. So here is the beams. So it will just take some sections of the beams and give you the design report. So as you are scrolling down, you'll be seeing the design report of the beams, and here are the calculations. These are the detailed calculations of the beams successfully. So the information you will see here may only consist of only the beams. All right, you can see the bending moment and the shear force diagram. Let me adjust this, and then you see all of the beam design report. Okay, now you can be able to create this using, like, convert it to PDF directly. If you click on this, this will take you to a directory where you will be able to save it, and it will be converted to PDF automatically, or you can as well convert it to Word automatically or to Excel automatically, and then you will be able to print your design report successfully. So you give it some time to actually export this to PDF, so we can be able to create the columns design report as well. So here is the report created in PDF and combined successfully. So let me just minimize this. All right, so now you can proceed to create reports as well for the reinforced concrete columns. So if you click in these provisions here, now you need to add a new, and then you give it a name as a column. report, just like this, and then you come to the reinforced concrete member over here, select the column and pull it to this side. So you can as well add both the columns and as well as the foundations. So if you want to add the part base foundations, you can also add it under here, just like this. You can see. Then for the slab, if you scroll down, you can see the slab report right there. Okay, so this one, if you expand it, you can see the slab mat design pier panel, but we did not use the pier panel options, so you can use the design summary right there, and then you had it under this. So you can also be able to arrange your design, your result or design calculations just like this as well. Click on the OK option. So if you come to the member report, sorry, over here we are supposed to make that active. This is beam that is still active. So if you are publishing, it is this beam that will publish. Okay, so the new one is columns. This one, click here to make it active, just like this, before you click on the OK option. So come over to the member. So in this member provisions, we are looking at the concrete columns this time around. So you can see the column summary. You can be able to create your own, see, concrete columns right there. So once you select that, you can be able to add the drawings and be able to add the design calculations. You can be able to add the calculation summary right there, and then the detailed calculations, calculation summary and detailed calculations. If you want to add the moment diagram, you can as well add it. So it depends on what you want to add, but in this particular interface you can only add these informations, design informations for just one member. You cannot add design information for maybe foundation and columns at the same time, you understand. So after you must have done with this, you now come over to create design informations, details for part footings. All right, so you click on the OK option, and then get back there again. You need to make it active, concrete columns, and then make it active. All right, click on the OK option, and then if you click on show report, so this report that is going to show now is going to be for the concrete columns and part of the slab, and as well as the foundations. All right, so while we are waiting for it to load, if you are yet to subscribe to our channel, and as well you can check the link in the description of this video. You have some templates you can use to fast track your detailing and editing. Also, you can reach to us if you want to enroll on the master class on this particular program. You can reach to us through the link we had in the description of this video. Drop your comment in the comment sections if this video actually helps you a long way. Put it down in the comment section. We want to see it. All right, thank you. So now you can see what we are having. So here are the diagrams. Here are the diagrams and the design calculations for the reinforced concrete columns. These are day calculations, you can see. All right, scroll down, you can see all of that for the columns, and then after which you see for these are the design for the footings. You know, we added the footings. All right, so the design for the footings successfully. So you can save all of this and then attach it to be able to submit your design project successfully. All right, so at this point I want to also ask you to like and subscribe to our channel. Thank you for staying through these presentations. And so if you have any question, drop it in the comment sections, and stay connected as we bring to you another useful design like this again. Stay safe. We will be stopping here. Bye for now.